All right, welcome everyone. In this discussion that we are to have, we are going to discuss issues to do with vaccines and the public health implication, of course, using the lenses of epidemiology. So we will first look at we shall first have an overview of the immune system, where we look at how the body responds to foreign bodies or antigens, and then from there we'll now look at what vaccines are and how they are actually manufactured, the different types of vaccines, and then we'll now look at the individual and public health effects of these vaccines, and then finally we'll look at what we call surveillance or monitoring and evaluation of vaccine programs. So that is basically the outline of this presentation. So the body can be invaded by pathogens. This can be viruses, bacteria, it can be protozoa, it can be any other organism that can cause damage or injury to any body organs or tissues. Okay, so the immune system usually responds to make sure that these pathogens cannot cause an infection, and if the infection is to happen, the effects are actually mild. Okay, and that means that it lessens the severity of the infection. Okay, so when you have a competent immune system, then likely you will not get the infection because the immune system will be able to neutralize the pathogens. Okay, and if the infection is to happen, maybe it can be mild and it is not very severe. Okay, if the infection has been established, still the immune system will be able to clear that infection. So there are two ways in which the immune system responds: a humoral immune response and then the cellular immune response. When we talk about the humoral immune response, we are basically referring to antibiotic-harming antibodies. Antibodies are proteins that are produced in response to antigens. Okay, so the antigens are basically molecules on the surface of the pathogens. Okay, that can make the antibodies to come and attach themselves to these antigens. Okay, antibodies themselves are also proteinous in nature. Okay, so vaccines usually stimulate the production of antibodies. So when these antibodies have been produced and they have attached themselves onto the antigen, and then the antibodies can neutralize the antigen, or you will have other immune cells coming in to destroy the pathogen. Okay, so that is the role of the antibodies. Okay, they help the white blood cells to recognize where the pathogens are, and then the white blood cells come and neutralize these these pathogens. Okay. So the second type of immune response is what we call cellular immunity. This is now we are talking about immunocells or cells of the immunity. Okay, so white blood cells are recruited. Okay, white blood cells, what we often call as the leukocytes. Okay, the leukocytes, and they can be B cells or they can be T cells. Okay, leukocytes can be of two types. They play an important role in the immune response. The T cells are usually phagocytic in nature, whereas the B cells are concerned with production of antibodies. Okay, so these cells still work together with the antibodies to be able to destroy the pathogens. So throughout our body, we have these cells surveilling to see that the pathogens can be neutralized when they appear in the bloodstream or in any other tissue. Okay, so when you have an infection that is systemic in nature, that means the whole body is having these pathogens causing the infection, then you are most likely going to have a systematic response, a systemic response to this infection. Okay, that means that the recruitment of all these cells of the immunity is going to happen in every part of the body, such that these pathogens can be neutralized. But we also have cells that we have white blood cells that are stationed in particular locations to be able to guard against any intruding or invading pathogens. So we have those in specific areas. For example, the tonsils. The tonsils formed around the throat. These help guard that area. We have lymphocytes within the tonsils that help in guarding the area against any pathogens. So the other very important cells of the immune system that I've just talked about are the lymphocytes, okay, which are found within the lymphatic system, and lymph nodes, and then the lymphoid associated tissues, or what we call the lymphoid tissues, okay, where you have the tonsils, the spleen, the thymus. All these are lymphoid tissues. So they have lymphocytes that also protect against pathogens. So we earlier on noted that vaccines help in the production of antibodies, and we have seen that the antibodies are very important in neutralizing pathogens because they can recognize what we call antigens that are found on the surface of pathogens. And then when they bind to these surfaces, they can neutralize these pathogen, or you can have recruitment of more white blood cells that can come and destroy the pathogen. So vaccines play an important role in production of these antibodies to be able to neutralize these pathogens. Okay, one aspect that we really need to point here is the aspect of immunological memory, which is that when you have a vaccine introduced into your body, then antibodies will be made, okay? And those antibodies will continue to be there until you have antigens that these antibodies can be able to recognize and then respond to. So that means that even after a long period of time, these antibodies will always be there to come and respond quickly when there is need. So let us familiarize ourselves with the terms vaccination, immunization, and vaccinology. Vaccination is the process of administering vaccines, and as we shall see later on, that the vaccine can be administered either orally or through IM, that is intramuscular injection, or through subcutaneous injections. Okay, so the process of giving these vaccines is what we call vaccination. Whereas immunization is about inducing immunity by introducing a pathogen-specific antigen. Okay. I'll still explain what an antigen is. We are saying that these are molecules, can be proteins, can be sugar, that are on the surface of the pathogen, and that are recognized by the antibodies. So the antibodies come because the pathogen is having particular molecules that we are calling the antigen. So the process of inducing immunity by introducing a pathogen's specific antigen is what we call immunization. Okay, what basically happens with immunization is that antigens are introduced into the body. Okay, these antigens are not powerful enough to cause an infection, but they can induce the production of antibodies, and then these antibodies can be within your body for some time, and that's why we are calling them immunological memory. That anytime you have a similar antigen, then these antibodies will be produced in significant amounts to be able to control the pathogen. Okay, so it means that for us to really get a very good understanding of how vaccines work, means that we need to have very good knowledge of microbiology, pharmacology, and immunology, and that is the field of vaccinology. Okay, so in this picture, the things that you can see, so this is a depiction of the pathogen. Okay, and then these extensions are the molecules that we are calling the antigens, which can be proteins or sugar. Okay, and then the Y-shaped molecules are the antibodies. So they come and bind on these on the antigen and then cause a reaction. Okay, where other cells can mobilize to come and also help in destroying the pathogen. So you have an antigen antibody complex that can be destroyed by phagocytic cells. So we talk about responses, say that these responses by the immune system can be categorized into two: primary and secondary immune response. Okay, so if you receive a vaccine, you will have what you call a slow production of antibodies, and this is what we call the primary response. But if you receive another dose of the same vaccine, you're going to have a faster production of more antibodies. Okay, and that's what we are calling secondary response. That means that when you have, this can also happen when you get an infection. If you get the infection for the first time, you have these antibodies produced, and they may not be in large amounts. But in the subsequent attack by the same pathogen, you're likely going to have a stronger response in terms of the immunity. And that second stronger response is what we call secondary response. And it will last for a longer duration. Okay, so because you have sustained production of antibodies, and then you already have cells that we call memory cells that will produce the antibodies because of the first infection made your body to be prepared, in that if the second infection comes, you have B cells to produce these antibodies to attack the pathogen strongly. Okay, so that means that immune memory cells allow a quicker and stronger response for when you get exposed to the same pathogen for the second time again. And this is basically what you will have. The first instance, if you get the first dose, you will get what we are calling primary immune response, which is lower and slower. okay, in terms of the production of the antibodies. The second time you get exposed to the same pathogen, the immune system response is stronger because you have B cells that produce antibodies, okay, to respond to the second exposure, and then you have a stronger immune response in this case, okay. So that is about the primary and secondary immune response. So why do we vaccinate? Of course, we vaccinate with the aim that people do not get these infections, okay? Because these infections can actually cause mortalities, okay? One of the key public health milestones is vaccination, okay? Vaccination has is attributed to cause significant reduction in child mortality. Okay, so it is a very strong tool to control mortality amongst children or among children. But also within the population, we have what we can term as vulnerable groups that are exposed to particular pathogens, and therefore immunization can be one of the ways to make sure that they don't contract these diseases. For example, health workers are vaccinated against hepatitis B, okay, because of the nature of their work, they are likely to to get into contact with bad foods, and if they are not really immunized, they are likely to get this hepatitis B. Okay, and then you also have people who are immunocompromised, and we have some diseases that are very prevalent in particular regions, and therefore it warrants vaccinations to take place. But generally, vaccinations are very important in controlling, eliminating, and eradication of diseases. Okay, we have diseases that have been eradicated, like smallpox. These are diseases that have been eradicated. And then also polio, though we have some cases, polio we can regard it as perhaps being eliminated, not completely eradicated, okay? Because we still have some cases reported in some, especially in Nigeria, we can have some of these cases there. So the knowledge of vaccines, like I said, is one of the key breakthroughs of public health, and it has caused significant improvement in the mortality rates. But where did this knowledge come from? Edward Jenner, who we described in our first lecture as one of the key personalities in the evolution of epidemiology as a discipline. Okay, so he's one of those key personalities that we can talk about. So he's responsible for introducing the first vaccine, the smallpox vaccine. It's the first vaccine that humankind has, humans developed first. Okay, so his idea came from careful observation, and we really need to note from this point on that careful observation is very important in control of diseases, especially in the field of epidemiology and public health in general. Okay, so we observed that women who were in charge of milking cows got a mild infection called the cowpox, and these women were not severely affected by the smallpox. So what she got was serum, uh, which we can term generally as materials from people who have been exposed, and then introduce these serum to people who are not exposed. And then when that happens, they actually become immune. So that was his observation. Okay, and then the vaccine through that knowledge, the vaccine had to be made. Okay, So that is what happened with Edward Jenner, who is one of the key epidemiology personalities that we can look at. Okay, so even the use of the word immunization and vaccinations has evolved over time. So the vaccines these days come in different ways. Okay, they are made differently in terms of chemical composition. Okay, so today we can have a discussion about these different vaccines, but tomorrow we will have vaccines that are completely different from these ones, especially during the COVID-19 pandemic. RNA vaccines were not very prominently used. So now with the COVID-19, the RNA vaccines are now being developed for different conditions. So this is basically to say that science is always evolving and different vaccines will always be created with different ways in which they work. That is very important to note that science is dynamic and is not static. So live attenuated vaccines, when we talk about that, we are talking about vaccines that contain weakened versions of the infectious agent. Okay, that means that the weak version cannot cause an infection in the person because it is weak, but what it has are the antigenic molecules that will cause the production of antibodies, and that is the interest. Measles, mumps, and rubella vaccine are made through that technique. And then the inactivated vaccines. Okay, these are killed versions of the pathogen. The pathogen has been killed, but the antigenic molecules are active to cause an immune response that will result into production of antibodies that will all be kept, okay, for production of more. The immune memory cells, so the B cells, will produce the antibodies when the same pathogen emerges again. And then the toxoid vaccine, you have inactivated toxins produced by the bacteria. This, of course, this vaccine still stimulates the production of antibodies. Okay, but these toxins are, of course, inactivated. So tetanus toxoid and diphtheria vaccines are toxoid vaccines. Subunit vaccines, you have specific components which can be proteins or sugars isolated from pathogens that can induce immunity. So basically, if you look at all these different types of vaccines, you realize that the end goal is that you should have antibodies being produced, and then these antibodies will be kept in the body such that if you have that infection again, the response is stronger. Okay, so whether you have the live organism, whether you have a dead one, whether you have its toxin, whether you get part of it, these are all different ways in which the vaccines can be produced. And then we have the conjugate vaccines, where you have attaching polysaccharides, which are sugars from the bacteria to a protein carrier to improve immune response. Okay, so a molecule is obtained from a bacteria and then attached to a protein, and then injected into the body such that you can have an immune response. And so that is a conjugate vaccine. And then the last two, this fly is also coming back. No, like this. Okay, the last two are about the RNA vaccines and then the DNA vaccines. The DNA and RNA, they are involved in production of particular protein, in protein synthesis, okay? But they are also genetic material. The DNA is genetic material. So with the DNA vaccine, genetic material, which is often the DNA, encoding pathogen antigens, and instruct the host cells to produce antigens and trigger an immune response. Still, it is an area that is under development or research. Okay, but at least with the RNA vaccines, these have been put into use and already in use. So what do the vaccines have? The vaccines have many components. They come, of course, the first thing are the antigens, which we say are molecules that can induce production of antibodies. They are found on the surface of pathogens. And we already talked about the different ways in which vaccines can be made to mimic antigens such that you have antibodies produced. The end goal is to have antibodies produced. So how you produce the antibodies differs, whether you use a weakened organism, whether you use a dead organism, whether you use a toxin, whether you use a DNA or RNA, whatever mechanism you use, the end game is that you should have antibiotics. Okay, so the antigen is very, very important part of the vaccine. Okay, and then the adjuvants. Here, we are saying that these are added to vaccines to strengthen their immune responses. So these are molecules that are added to vaccines to add or to strengthen their immune response. So they can be minerals, they can be aluminium salts, phosphates, and hydroxide. They can be any molecule, as long as that molecule that is added to the vaccine will produce a stronger response from the vaccine. Okay, so they work by stimulating the innate immune system. So depending on the nature of the vaccines, other components can be added. Preservatives, antibiotics, stabilizers, and expansers. These are other things that can be added to the vaccines, okay? So that means the addition of these properties depends on, the addition of these components depends on the properties of the vaccine. If the vaccine can easily lose its potency, then it is likely that you need to add some of these components, stabilizers, expansers, and preservatives. Okay. So good vaccines should be of good potency, stable relatively on when you look at temperature ranges, issues of immunology and safety. And we are going to explain each of these to understand what they really mean. Okay. You don't want to have a vaccine that is of a large amount. You want a vaccine of smaller amount to cause the response that you want. So that is a concept to do with potency. So vaccines, usually you will see that they are contained in small vials. Okay, this is because they are highly potent. You cannot have a vaccine that is about 10 mils. If you have a vaccine of 10 contained in 10 mils, that is a lot. Okay, so that's why you have vaccines usually in units that are very small. Okay, international units, AI, and then nanograms. Okay, so that is an issue to do with the potency. If you don't store the vaccines properly, the vaccines will lose potency. And usually you have temperature and light as some of the key factors that can influence potency of vaccines. So we already talked about the different ways in which vaccines can be administered: intramuscular, oral, subcutaneous, and intranasal. And we will not focus a lot on that. But these methods have implications in public health. The first implication is about the technique of delivery, of the technique of administering these vaccines. You want to have vaccines that can be administered by even the low-trained health personnel should be able to administer them. So that is one aspect. The other aspect that is very important to public health is what are the things that are needed for administration of this vaccine. Okay, is it a syringe? Or if it is a syringe, what type of syringe? Okay, and then you look at the cost associated with that. Those are the things that have public health implication in terms of you deciding or making a decision. And then the stability. If you don't have refrigerations, yeah, and especially refrigeration systems will need power. Okay, if you not have a national grid, then you will have problems with maintaining the cold chain. Okay, so if the vaccine loses its potency because of the conditions, it could be the temperature or light, then you have a problem with its stability. Okay, so you want to make sure that the cold chain is maintained at +2 to +9 degrees centigrade. If you can't maintain this, then you will have an issue. The third property is what we call immunogenicity, which is the ability of a vaccine to trigger a protective immune response. Usually, if you administer live attenuated vaccines, you have a more immunogenic response than the other types of vaccines. One of the key issues that we have in public health with regards to vaccinations are issues to do with what we call vaccine hesitancy, that people were hesitant to get immunized or to get their children immunized. And this was actually particularly very common in COVID-19. So one of the key issues that are raised in these situations are issues to do with safety. Okay, the safety profile of these vaccines. When we talk about safety profile of these vaccines, we talk about whether these vaccines can cause severe side effects. Some of the vaccines for COVID-19 have been recalled or their production has been stopped because of very fatal adverse reactions. And the blood clots have been associated with some of the COVID-19 vaccines. So that means that safety is an important issue to do with public health, especially acceptance of vaccines and their uptake. Okay, so these reactions can happen immediately after the vaccine has been administered, or they can happen after some time. And we'll look at the different factors that can happen, that can influence whether the reaction is immediate or not, and how can you document that for purposes of surveillance. So rectogenicity is about the side effects that happen immediately after the vaccination. This can be, of course, the pain and then the fever can happen immediately. And then you have vaccines that don't have a lot of side effects, and they're definitely well tolerated. Okay, and therefore, with the issue to do with the safety, it is very important for public health professionals to be aware about the prevalence. Okay, the prevalence of adverse events following immunization, and we shall look at this in more details. Okay, the different factors that we have talked about, they don't occur in isolation. Potency influences immunogenicity. Immunogenicity has an influence on safety and the side effect profile. So they work, there's an interaction, okay? But definitely you want to have vaccines that are of a low side effect profile, okay? You don't want to have vaccines that are usually having side effects that are fatal. For example, the blood clots that we hear associated with COVID-19 vaccines. Okay? So Some of these vaccines, of course, are under development, and therefore sometimes the complete knowledge about these vaccines is not available, yet these vaccines are actually needed. And this is what basically happened with the COVID-19 vaccines that were in the market. Okay, some of the clots, for example, became well documented well after the pandemic is subsiding. Okay, that's when the real documentation of this, or the evidence for these blood clots, actually became very, very apparent. Okay, so that means that post-market surveillance is very important in noting these side effects that are very grave. Okay, so vaccines are very important, and they induce immune responses in humans and also in animals. It's not only in humans that they can induce these responses. Of course, our interest is in humans. If you have the immune response being activated, you have these memory cells. That means that every time you get an infection, you will have the antibodies available to deal with this infection. And therefore, you have reduced chances of actually getting this infection. And if you get the infection, the chances that it will be very severe are actually reduced. Okay, and that is what happens with the vaccines at individual level. Okay, so there is reduced chances of getting the diseases. If you get the diseases, if you get the disease, and then you have reduced chances of the disease progressing to the severe stages. Okay, that is what happens if people are vaccinated. At the population level, the impact or the effects of the vaccinations can be felt when, of course, one, you have a larger population being vaccinated. Two, and if these people who are vaccinated and those that are not vaccinated can mix randomly. Okay, we explained this in the lecture to do with communicable disease epidemiology, where we talked about herd immunity and the conditions that should be in place for herd immunity to be achieved. What we said in that presentation is that if you have majority of the people vaccinated against a particular disease, then those who are not immunized are actually protected. Why? Because you have reduced chances of them meeting someone who is not immunized, and therefore their exposure, the chances of exposure to pathogens is actually reduced, and that is the concept of herd immunity. And the conditions are four that we listed in that presentation. Please check it out as soon as you can on the YouTube channel later today. We shall upload it. Okay, communicable disease epidemiology, and watch it. It is a 1-hour lecture that you really need to watch. Okay, so we are saying at the population level, it is important that the coverage is large. Then two, that the people who are immunized and those that are not immunized, who we have called the groups, should mix randomly. And if you have that, then you can achieve herd immunity. So vaccines at the population level, which is basically our interest in public health, you can have indirect effects where those that are not vaccinated still benefit because of the majority of the people being vaccinated. Overall, when evaluating whether to vaccinate a particular population or not, you weigh the impact of being vaccinated and not being vaccinated, and you can use economic evaluation strategies, economic analysis to come to a conclusion whether there is a benefit associated with the vaccination campaign. And we shall look at that also shortly in this presentation. Okay, so overall, if someone receives a vaccine, their body will have to produce antibodies, and then you will have memory cells that will produce the antibodies later on if you are exposed again. That is what happens. But this response also varies across individuals. This is to say that the response is not going to be uniform for every individual. So the responses can vary depending on the vaccine characteristics, what the vaccine consists of, and how it is being delivered, and actually the intervals of administration, which we call the administration schedule. And then we now look at the person who has received the vaccine, the recipients. Okay, we have those that will have mild side effects, and then we have those that will develop serious side effects, okay, fatal side effects associated with the vaccine. So the reactions will not always be the same, and we have a number of factors that play.